Hi, so I'm actually going to do today a little bit differently. So I'm actually going to go ahead and basically solve part 2 only and then modify it to use part 1. And the reason why is that ends up making it like a nice little solution. But yeah, so let's go ahead and get into it. I think if anyone just wants help with part 1, like the naive approach, I can kind of make a video for that, but I just don't think it's too important. And there's also like a lot of other great resources for that. It's fairly straightforward. But yeah, so we basically end up with a set of rules like these workflows, and then we get a set of points. And we're basically just seeing if they're valid. And valid would mean they end up with the A state, and not valid if they end up with the R state. So for part 2, we basically want to see how many possible valid things there are, given that they could go from 1 to 4,000 inclusive. So to solve this, let me go ahead and delete my existing code. Get main input. All right, here. So let's go ahead and so we'll go ahead and start parsing the input. So workflows raw and then parts is equal to input. If we split it on this, we'll split it on this kind of double space we see here. And then now we'll go ahead in here, and then we'll go ahead and create our workflows, just in a parsable kind of format. So this. All right, so for each line, we're going to do name rules is equal to, and I'll explain this in a second why I'm doing this kind of weird line. So if I print out name rules, and I'll run it just on my input, or I'll run it on my test cases. I also did add a couple, I think like one test case of my own, but here you can basically see that name is going to be equal to this px, and the rest is going to be just inside this text. So I'm basically cropping off this last character, which is going to be this curly brace every time. I'm splitting on this opening brace. So I'm getting this entire part as my rules variable and this as my name variable. And then finally, I'm going to go ahead and just put this into my dictionary. So workflows at name is equal to rules dot, and I'm going to split it on the comma, just so that I kind of have like all this data ready to go. So now that we have this, we'll go ahead and let's start creating our range class. So I'm going to import two things: import re for regex, and I'm going to import from copy import deep copy. And I'll explain why, and you'll see in a second. So don't worry too much about that. So we're going to have a part range. Okay, we're going to of course self, and then we're going to have ranges, and we're going to take a default argument. And then I'm going to set self.ranges is equal to deep copy on whatever ranges is, or here. Let me write this line, I'll explain it. Alright, so what this is doing is I want to be able to create basically a copy of this class if I pass in just the range, but I also want to create a new one if I don't have that. And the problem is if I do something like for example, if I just did something like this, the problem is this list here is actually shared between all instances of that class, and it ends up kind of making some bad things. So if you're interested, just like leave a comment and I'll send like some links and some small little reading. But yeah, so basically we're gonna just set this as none, and then what this is doing is if this is none, then it automatically Python will return this. So we'll basically create a new list. If it isn't none, then we create a copy of whatever it is so that we aren't mutating the same thing that gets passed in, and we set that equal to our ranges. So now that we have this, let's go ahead and do our def split on. So what this function will basically do is I want it to return me. So for example, the general logic is I start off with a range of like 0 to 4, like 1 to 4,000 basically. And then inside that range, when I get to something like this, I'm going to split up my range based on this. And the part that does satisfy this condition, I start evaluating on state px. The part that doesn't satisfy it, I start just continuing. And then I basically do that until I run out of all my kind of ranges, and then all my remaining correct ranges have to be my solutions. All right. So, and then also, the format I'm using is basically, I'm treating it where this range is strictly less than like val, like this, where it's not inclusive on either side. I think that makes it nice, partially because my inputs, like these inputs, always are just greater than or less than. And so you'll see what's kind of nice in a second. But, all right, so go ahead and create an in range. And this is going to be equal to a new part range, a copy, that takes in this. And this will also be an out range. So in range will be the part that's satisfying the current condition based on this. And this LHS is based on like the left-hand side. And you'll see when I parse it, like it'll make a little bit more sense. But basically, this left-hand side is just like this section, left-hand side of the rule. All right, so let's go ahead and parse just the number. So that's going to be, if this is my left-hand side, always one letter, always one letter. So I just get 2 characters just to get the int. So now that I have that, we'll do existing range is equal to in range, our ranges, just 0. This is just a little bit of like, just writing it once so I don't have to keep writing this entire thing. So we'll do if existing range at 0, so the lower bound is less than equal to num, is less than equal to existing range 1. So if it is currently, like the number we're splitting on is inside whatever the bound we're looking at, then that means I'm going to have 2 separate defined ranges. So we'll do if LHS1 is equal to greater than symbol, meaning we're in this case, then I want my inside range is lower value, so range is LHS0, and this LHS0 is going to be the letter that we're working on. And since this is a dictionary, it will just access that range. So the lower value should be now equal to whatever my number is. Then here, my out range, so my out range's higher value should be equal to the number. But also keep in mind, since this is greater than, one bug that I had is the opposite of s being less than 1351 is s being greater than or equal to 1351, which is the same as saying s is greater than 1350. So I'm going to go ahead and I'm actually going to add 1 to this. And so the reason why is if I have the case where this is the opposite sign. So if I have this case, the inside range is going to be the lower bound should be set to this. The opposite of this should be the higher bound should be set to this plus 1 to include this number. Because if x was 2662, this would be false. And for the opposite to be true, I want my x to be less than or equal to this number, or less than this number plus 1. So now that we have that, let's go ahead and do the elif state, which we can just do as else. But this is going to be equal to the less than state. And so for this, we're instead going to set the upper bound here, and then we're going to set the lower bound here, along with, along with this being now a negative. So there's a nice little symmetry to it, and you can kind of walk through some examples to get why this is the case. But all right, so now we'll add the other cases. So if, there's probably a nicer way to do this, I just am a little bit tired and it works. And so we'll go ahead and just kind of keep going with this. But here, so if my number is lower than whatever my current range is, and I'm telling you that my solutions, or like to kind of go down this branch, needs to be greater than this, then we'll just set out range is equal to none to represent there's no complement, like no outside part of the range. Like, so for example, if my range is, let's just say our range was the default 1 to 4000, and I say, oh, if x is greater than -4, go down this branch. That should always run, and that's what this is saying here. And then now we'll go ahead and also add 1 for nice little symmetry again. If I could, all right, here. Oh, oops. All right, so here. So if it's greater than the upper bound, and we're saying if you're less than, same thing. And then finally, go else in range to out range equal to none. So basically saying if it's not one of these previous cases, this means it's an impossible range. So like if I have the range 1 to 4000, and I'm saying, hey, it has to be less than -2, this will never happen. And also, fair warning, there are no negatives in this problem. I'm just saying this as an example. But yeah, so now we'll return in range and out range. So the first argument is going to basically be the range that follows the condition, and the second part is going to be the part that's outside of that condition, but still part of whatever our original range was. So now that we have all of that, let's go ahead and let's make our function to kind of get all of our valid ranges. So we're going to create valid ranges as a list, and then what we're going to do is we're going to create a function here. So we'll do test range, and it's going to take a part range, a name, and that's it. And so if part range is none, return, and we don't have a return type or anything like that. This is basically just to, if I ever get a none, meaning there's no valid range, I just stop. And then now if name in AR, so if I'm currently in a workflow, and the workflow is either an A or an R, if name is equal to A, then I want to valid ranges.append part range. So here I'm basically just saying, go ahead and if I eventually end up and I basically say, like, hey, this part range, I'm currently on rule A, add that to here. If it's rule R, just stop. All right, now in the else, this means that we have a current workflow. So we'll do rules is equal to workflows at whatever our name is. And then now, for our in rules, for each rule, if there's no colon, then that means that we just end up with something like this, where we're at one of these states where it's just automatically go ahead and do the state. So for that, what we're going to do is we'll do test range, part range, whatever current range is on that new state. And then otherwise, this means we do have some condition. So we'll do left-hand side, and our next state is equal to r.split on this colon. So for example, if I get something like this, like a rule, I'll split it on this colon, and we'll get our left-hand side here. And this is the same left-hand side that I'm passing into this. But here, so now we have this, and we'll do in range, out range is equal to part range dot split on our left-hand side. So this is now calls our prior code to kind of split up our range. So first things is we're going to want to keep testing our range on whatever the next transition is. So for example, if we have this, our code will go ahead and give me the range that from our prior range, the range that satisfies this, or none if it no longer exists, and then tell you that, hey, keep doing this on QS. So that gets taken care of here. And now for the other range, where we just keep continuing down our rules, we'll just do part range is equal to out range. And if part range is equal to none, we'll return. So this is basically saying, hey, if you end up with something like the entire range is inside of the condition, then we just stop processing. But so now, with all of this, if I go ahead and call test range part, and I'll give it a dummy part range, like a complete full part range, and I'll give it to in, let's see what we get for our valid ranges. All right. So it looks like we're getting some stuff. I don't have a representation or any kind of print, so for now we'll just kind of check it. When I actually wrote it, I did add my own representation function, like I can show it here. I added this, or here. Oh, I deleted it for my kind of edited version, but I did have like a representation. So I'd recommend that if you're writing this and stuff like that, have your own prints. But since I'm fairly confident this works, I'm not going to add that now. But here, for part 2, I'm just going to do this. I'll need some way of getting the actual score for the PR invalid ranges. So for each valid part, I'm going to go ahead and add its score. And the score is going to be a function we write here. And what this should do is basically tell me how many possible combinations there are here. And the nice little property I have because of this is once I start with this part range here, which is all 4,000, 4,000, 4,000, 4,000, I'm never going to have overlapping ranges because of just how I wrote this. So I don't have to worry about that. And then to score my function, I'll just do answer is equal to 1, for LH, so low and high in self.ranges.values because it's a dictionary. Then we'll multiply this by h minus L minus 1. A little bit of trial and error on this math, but I think just toy around with some examples that'll make sense why. And then here, return answer. So now, if I run this test, you can see we're actually getting the right values. And yep, so part 1, I have no answer, but part 2, you can see we get the right answer. So for once, part 2 solved before part 1. So now for part 1, what we're going to do is, first of all, we're going to create a utility function here called def in range. And it's going to take any number of arguments like this. And then now what I'll do is for LB, and so you'll see why, but basically what this should be is I pass in X, M, A, and S as separate variables. And then so now for this in zip xmas, and then whatever my input variables are, if not self.ranges, L. So for each letter in xmas, and then tied to whatever my arguments are, which would be X, M, A, and S from whatever an input range is, I'll go ahead and return if it's not satisfying this condition, meaning it's inside the range, return false. Otherwise, return true. So, sorry. Let me go ahead and kind of show you how we're going to use this. So now, we'll do p1 is equal to 0. I'll return this p1 first of all, get that out of the way. And now, so for p in parts.split lines, if I just print out my p, you can see we're printing out stuff like this. And they're always in the exact same order of X, M, A, and S. So I'm just going to go ahead and extract these to variables. And I'll do this is equal to map int read.find all, and then a regex to just get all of the digits. So I'm getting basically capture any digit one or more times, and then with all of those, I'll map it to integers and then extract them to these variables. So now, if for any part for PR in valid ranges, so for any part range here, if PR dot is in range, I pass in X, M, A, and S. So I'll explain this a little bit more. P1 is equal to X plus M plus A plus S. So if I go ahead and test this out, you can see we're getting the right value. If I submit it, you can see we get the right answer for both. But one little kind of Python thing here is notice I'm passing 4 arguments. When I call this function, this star is basically saying, hey, I'm going to give you some amount of things. Just go ahead and put it all into this list and like automatically kind of infer how many things should be in here. And then so, sorry, it parses all of this into the list here. And so now that we have that, we do this for each of the parts. And if the part is in any valid range, then it's a valid part. And then we just sum all of these variables and put that for part 1. For part 2, we have part 2's. But yeah, let me know if you have any questions.